Hello everyone, my name is Amira. This project aims to group customers of a retail store based on their purchase history using the KMeans clustering algorithm. In this video, I will show to you how to use KMeans clustering algorithm. You can download the data from this repository, this file, mailcustomers.csv file. We will build a system to cluster customers into different groups. So, for example, we have clustered the customers into 5 groups. Say that 20% of customers have purchased something and 10% of customers have purchased another something, and another example that some clusters of customers don't purchase anything. So that is the result of our customer group. So having these groups of customers will give us better insights and details that help you to make better decision making or better marketing strategy and so on. So this is an example of cluster machine learning project. Clustering algorithm is unsupervised learning. Now let's try to understand the workflow which you are going to follow. First of all, you need to download this customer data so that we can feed our data directly with our machine learning model. The next thing is data processing. We need to process our data so that we can get the features which we are needed to train our machine learning model and get the clusters group based on the features you have get from previous setting. Then we need also to analyze the data to see which features are important to us and what features are not important to us, such kind of things. After that, we need to choose the current number of clusters. So what is cluster? Cluster is when you tell your machine learning model cluster our data into 5 groups or 4 groups or 3 groups. So first you need to know how many clusters you want to cluster. That means you want to split your data into how many groups. So we find that number by using WCSS, which stands for within customers sum of squares. So we will try to find this WCSS value. It tells us the current number of clusters. We will implement this in the code. Once we have the number of clusters we need, we can feed this data to our KMeans clustering algorithm. So once you feed this algorithm with the number of clusters, it can group your data into number of groups that you have from WCSS depending on the similarity between groups. And finally, we will visualize this. We will draw the visualization using matplotlib library that will draw each group he had cluster. So this is the workflow which we are going to follow. So now let's get started with the coding part. I will do this programming in Python programming. First of all, if you are using Windows as operating system, you need to write this part of code. Import os.environment obnum thread equal 1. If you don't write this part of code, you will get that error. Warning is KMeans is have to memory leak on Windows. So this issue will be solved if you write this code. Now the first step which we need to do is import the dependency so that we will import this library that we will use in this project. Import numpy as nb. So this is useful in making numpy arrays. Import pandas as bd. This is useful in making data frame. We will use this library in loading our data. Matplotlib and seaborn are useful in visualizing our data. From sklearn.cluster import KMeans. This is our algorithm we will use to cluster our data. So this is the dependencies which we are need. So to run the cell, just write shift and enter. See, this number means that your cell have successfully run, and if this number is a star, it means that your cell is still running, and if your cell is in yellow, it means that this cell it haven't hand run yet. So the next step is about data collection and analysis. We will load our data here. We will load our data using pandas. We have import pandas as bd, so we will use bd instead of writing pandas. Just make any variable name here to store your data, and then to load your data, write bd.ratecsv and the name of your data. This data you can download from this repository, from this, and the file mailcustomers.csv. If you want to see only the first row in your data frame, just write the variable you have stored the data in and then .head function. It will give you the first 5 rows. We just want to see what was the data about. It's include customer ID and gender and age and annual income and spending score. Now let's try to find how many rows and column in this data frame. Just write your name of your data frame you have stored in df.shape. This function will write to you the first index is row and the second index is the number of columns. So totally we have 200 number of rows and 5 number of columns. So this is the shape of our data set. Now if you want to get some more information about the data set, just write the function .info and the name of your data frame. So we have 200 entries and 200 row and data column total 5 columns. So we have 5 columns and the features in the column customer ID and gender, age and annual income and spending score. And it tells you also the non-null value. Non-null value means there is no missing value, and the type of each column. The type of customer ID is int, and the type of gender is object, and the type of age is int, type of annual income is int, and the type of spending score is int. And also we can get more information about the missing values in our data set. Just write the name of mention the name of your data frame and dot is null function dot sum. sum. Is null function, it checks for the null value, and dot sum, it will get the sum of number of values you have missing in your data frame. So because we don't have any missing value, we all have non-null value. That's why we get the sum is 0 here. So this line of code will show you the number of missing value in your data frame. So now we need to choose which column. We need to make clustering based on the column we choose. We can see here we totally have 5 columns. Customer ID, so we don't want this customer ID because it's not required. We are going to group our customer based on spending score and annual income. So we are going to classify our group customer based on these features, annual income and spending score. So now I'm going to choose these 2 columns alone. We will doing this by write your data frame .i locations because we are going to locate a specific 2 column, and we write column here because we want all rows, and for column section write only from 3 to 4 because if we come back to the data frame, counting in Python starts from 0. So customer ID is 0, gender is 1, age is 2, annual income is 3, spending score is 4. So that's why we write here 3 and 4. So after that you slice your data frame, just write dot value to get all values of just 2 columns. And if you want to see the values you have sliced, write x that you have stored the 2 column. You will see this 2 column, right? See here the first value is 15 and 39. If we come back to the data frame, we see 15 and 39. So this is the value of 2 columns. The next step is to choose the number of clusters. We will choosing the number of clusters by choosing a parameter, and this parameter is WCSS. We can find within cluster sum of square by using this formula. Tends to find the distance between each data point and their centroid. So you can see here each cluster represents a data point. So this point is near from this centroid and this point is near from centroid. So he make cluster for this group and he finds some point here and he sees that all this point is near from each other, so he makes this centroid here, and based on that he see what other point is near from this centroid. Based on that he make cluster this group, and the same for this point. For finding the WCSS value, we are building a plot like this. This is elbow graph. So this graph shows you which number of clusters has minimum WCSS value. That means which number of clusters has the least value difference from centroid and the point. So in this case we are going to create a for loop in each cases. So in the first case we will find the CSS value considering for 1 cluster, and we will do it for 2 clusters, and then for 3, and then for 4. All the value till 10 clusters, and in these 10 clusters we will try to find which number of cluster has minimum WCSS value. So we will create here an empty list WCSS. So we'll make for loop here for I in range 1 to 11. This will take the value from 1 to 10. That means we will search for the number of clusters from 1 to 10 that has minimum WCS value. So this loop is iterated from 1 to 10. After that, to find the number of clusters which has a minimum WCSS value, we will make a variable named KMeans, which we will load our algorithm KMeans, and this KMeans gets 3 parameters. The first parameter is number of clusters. We will equal this variable to I. I is the for loop from 1 to 10. So number of clusters, the first loop it will be 1, the second loop will be 2, and the third loop will be 3, and so on. And second parameter is init equal KMeans plus plus, and the third parameter is random state. So you can give this parameter any value. I will give this parameter 42. After that we will fit our data with this KMeans. What data we want to fit? We want to fit our data with KMeans for this only 2 columns. So that's why we have split our data and taken the column 3 and 4, and we store this 2 column in x variable. So we will fit KMeans with this x variable. So we want to append the KMeans inertia that we will get from this line into the list we have just created here. So that we write here WCSS.append KMeans inertia. We will plot the WCSS values. So when you write this, it gives you the WCSS value for each cluster, and it will be stored in this list. So now we need to graph the value of WCSS that's stored in the WCSS list to determine the minimum value of WCSS. So that we will plot an elbow graph by writing here say snc.set. snc is the abbreviation of the library seaboard. When you write this line, it means that you set the parameter of the graph, and we will plot our graph in the range from 1 to 10 and write in this range the WCSS value, and we will title our graph the elbow point graph that we have done here, and the x label will be the number of clusters, the x label number of clusters, and the y label will be WCSS in the y label. And then to show the graph and appears to you, write plot.show, so the graph will be shown to you. So now if we analyze this graph, we will see a cutoff here that stands for 3 clusters, and then if we continue we see another cutoff here which stands for 5 clusters. So now we have 2 elbow points, 3 and 5. We will take this 5 value. So we have optimal number of clusters is 5. So now we have the number of clusters. We use this number of clusters. So now we will training the K-means clustering model, and in this case the K is equal to 5. So we'll write again this line, but this line we now have the number of clusters, so we write K-means number of clusters equal to 5 and initialization equal K-means plus. And again the random state we will mention any number you want. I will mention here 0 number. After that we need to return a label for each cluster. So what we are going to do, we are going to take all the value from this particular data set, these 2 columns that we have split it from the data set, and we will give them a label. After we cluster them, each point is now in a group of clusters. So we have 5 group of clusters, so each point is now have a label. We'll have a label 0 or 1 or 2 or 3 or 4 because we have 5 clusters. After that we will visualize our clusters. So we want to know each point of this x value which is contained in any of these clusters, 1 or 2 or 3 or 4. So we write this line here, K-means.fit predict x. This is our value which have the 2 columns we have split from our data. After that we will print y, and this is the labels we have just, and this is the label. After that we need to visualize our cluster. So our figure will be in weights of 8 and a height of 5, weights of 8 and a height of 5. After that we wanted to graph each point in its group cluster. That's why we have right here plot.scatter x y y equal 0 0, x equal y y 0 1, s c equal green, label equal cluster 1. What does this line mean? X, this is our data which contain the 2 columns, annual income and spending score, and y equals 0 0 0. The first index is represents the number of clusters. So the first index represents cluster 1, and the 1 represents cluster 2, and the 2 represents cluster 3, and the 3 represents cluster 4, and 4 represents cluster 5. The second column represents the annual income. Because we want to graph these 2 columns, the first column is annual income and second column is spending score. And we have stored these 2 columns into the variable x. So x now contain only these 2 columns. So the first index of x is representing the annual income, and the second index 1 equal to spending score. So that's why we write in this all columns 0 and they write in these columns all 1, because we want to graph all the points in these 2 columns into each cluster group. So the first index represent here the number of cluster group, and here represent the first index represent the number of cluster group, and the second index here represents the annual income which is index 0 column 0, and the second index here 1 represents the spending score column, and s equal 15 which is set to the size of the scatter plot equal to 15. Cluster 1 equal be green, and the number of cluster and the red and the color of cluster 1 will be green, and the color of cluster 2 will be red, color of cluster 3 will be yellow, color of cluster 4 will be violet, color of cluster 5 is equal to. So now we came to an agreement that x represents the annual score and this represents the spending score, which is this graph the point in annual income in x-axis, and this will graph the point in spending score, will graph the value in spending score in y-axis, and will cluster each one in each group it's contained. So this is will the result. It will draw each point in each group, and x label will be annual income and y label will be spending score, and the title will be customer group. To draw this centroid in each cluster group, we write plot.scatter K-means.cluster centers. We want to draw centers for each 2 columns, so we want to draw center for the 1 column which is index 0 and the 2 column which is index 1. So the first thing we select all the row, and the second index is 0 which represents the first column, and K-means.cluster centers, which here we are drawing center for the column 2 and all rows, and the size of the scatter will be 100, and each color will be cyan, and each label will be centroid. Here is our graph. This graph shows us that from 20 to 40 annual income, cluster group has minimum value spending score from 0 to 14, and we have another cluster group which have higher annual income from 18 to 100 but also have low spending score. So from these 2 groups we can give them a discount to get high spending score. And also we have a cluster group here from 14 to 80 annual income and from 40 to 16 spending score. So this group is not much high spending score and not much annual income, it's medium between them. And we have a group here which have a low annual income but high spending score, and this group have high income and have also high spending score. So this is all the project, and thank you.